Hello guys, welcome back. So this week we will be studying about completeness, a complete statistic. But we often don't know, the reason why we're introducing completeness, the core reason behind completeness introduction. We have already done sufficiency in the last week. So today's video is directed towards understanding why completeness idea is very important and I will share a bit of a definition and I will be a kind of a overview of uh, why it's important. So, if you remember that, what was the goal that we started with? Our goal was to find an UMVV, right? That means an unbiased estimator, which is minimum variance among all the unbiased estimators, and yeah, that's it. But for all parameter value theta. So let's see how our idea of sufficiency and completeness can help together. So we'll first go into sufficiency idea. So sufficiency says that x curl given the tx curl, the distribution of this is independent of the parameter theta. So I mean this way of writing is not okay. But you can write this because theta is a real number here, but you can write this, okay? It does not contain the parameter theta. You can say in that way. So, but theta is not a random variable here. So independence kind of idea, you can understand what it means. So now, let's take an unbiased estimator U. Okay. So what I will do is that I will use it U to form another unbiased estimator. That is U given this sufficient statistics Tx. U is a function of x only, so let me write it in a different way. So U of x, okay, let me write it in the previous way only. U, and U is unbiased, and this notation is for unbiasedness. And we'll check the properties of this too. Very interesting properties are there. We'll use the Tower property of expectation, smoothing property of expectation, or Tower property of expectation, Adam and Eve's law. Which says that expectation of x given y is expectation of x. This is taken over x and this is taken over y, because this is a function of y. And x variance of x is nothing but variance of expectation of x given y plus expectation of variance of x given y. Plus expectation of variance of x given y. Let me shift it a bit. So now, using this, observe that if we put another expectation, we know that expectation of u is equal to corresponding theta. We know this unbiased because of this property. So we can understand if we again put an expectation on this, it will check that it becomes unbiased too. So this u given tx is an unbiased estimator of theta. And similarly, you can check that using the star property. I'm not going to show it, I will show it in the class, that variance of this u given tx, sorry, expectation of, so this is expectation of u given tx, I'm so sorry. this is a new function, is actually less than equal to variance of x u. That means this new statistic, or I don't know whether it's statistic or not, let's see, is also unbiased. But there's a question. The question is that since we're taking expectation, okay, so of course this element will be a function of the random variable tx, but since the expectation over u, it can also be of contain parameter values, right? Since we are taking expectation integrating in contain parameter values, but this will not contain parameter values just because tx is a sufficient statistic. So that's why the importance of sufficiency comes up. We are getting an estimate just based on t. Okay. If it was not sufficient, then theta, the parameter values could have come up into this expression, which wouldn't have sufficed our purpose because our purpose is to get a better estimator than you. So therefore, the sufficiency idea is inbuilt in this fact that it's a function of only. Okay. So this is very, very important in understanding. And so these are the things that you can check. And the second thing is that why completeness? So similarly, you can do this like, so you can do an same procedure, right? You can keep on taking, sufficient statistic or sufficient statistic or sufficient statistic till you get a very good estimate, right? But how do you know it's UMVUE? The thing is that, I mean, therefore you will get an UMVUE, right? But thing is that if you take another estimator U1, another estimator U2, and apply the same procedure, okay, to get, let's say, some xi1 estimate and some xi2 statistic. These are two statistic, okay, which are claimed. So therefore, the idea is that we will see some Lehman-Schiffer-Lehman Rao-Blackwell theorem where they're dealing with this thing ideas. I will go into deep depth. That using this process, we can find an UMVV. Okay. But let's say using two different unbiased estimators, because there are a lot of unbiased estimators. So using two different unbiased estimators, we can get two different UMVV statistics. But we want UMVV to be really, really unique, right? We want it to be unique. Or whether it will be an UMVU or not, that's also a question. So to want it to make it unique, that means to make it unique, understand this very carefully. We need all this to be same, right? So the idea, the thought process went like this. To make it unique, they must be same, right? So therefore, understand these are nothing but function of the sufficient statistic t, right? Or you can also, yeah, so function sufficient statistic t, f1t and f2t. Right? Now, these two are equal. That means not these two are equal, but they're expected, of course they're equal. So their expected value is also equal because they're unbiased. The expected value is also equal. Right? So it implies that we can write this as expectation of f1t minus f2t is equal to 0. So let me repeat once again, you have two unbiased estimators using the same t to find two different UMVUs by some procedure that I will tell you in the class. But this procedure you can understood above, it helps you to get a better estimator, right? So therefore, you can use this procedure to get a better estimator and hence an UMVU too. We will see it how. But in this case, if you have two unbiased estimators and you follow the same method to get two UMVU, F1T and F2T, We want to make sure that it's unique. We want to impose the conditions so that it's unique, it becomes unique, right? What condition will make it unique, right? We know that uniqueness is mostly the case. So what condition will make it unique? So you can see that if expectation of f1t is equal to f2t, so we want f1t is equal to f2t. And the condition we know is that expectation of f1t is equal to expression of f2t, and then umvu2. So the umvu, that it's an umvu, okay? That is, it's an umvu that is done by the statistic, the sufficient procedure, right? Sufficiency procedure that I showed above, plus that smoothing property the condition. But to maintain its unique, we just need the fact that they're unbiased. So therefore, we need that if expectation f1t is the expression f2t, then of course it will imply that they must be same. That means the estimators are same. So that means this will imply that f1t minus f2t is equal to 0. In other words, f1 and f2 can be really, varied all over. So make it a general theorem. They wanted that if this is g of t, that means g of t must be equal to 0. So therefore, they tell you that if expectation of, so therefore the completeness goes like this, that expectation of g of t function at t is called a complete estimator if for all functions g, for all g, if expression of gt is equal to 0, sorry, I'm so sorry, if for some g, expectation of g, because f1t and f2t will be fixed, so for some g, if expectation of gt is equal to 0, then g of t must be equal to 0 with probability 1. But yeah, that's right. That means will happen almost surely. That means in sense that it's equal in some sense. So therefore, this is the basic idea. So therefore, UMVU is done by sufficiency and conditioning, and uniqueness. The uniqueness part is being offered by the completeness, and this is why the completeness is really useful and why it came into being. So to make it unique, because in probability many things can happen, right? So to make it unique, these two things are important. You will see that using a complete sufficient statistic, not complete or not sufficient, just both of them, we can find a unique UMV in the classes. So this is the basic idea of why completeness is important. I hope you enjoyed this. Yeah, so I will see you in the next video, and stay tuned and stay blessed. And if you have some suggestions about different content you want, or if you have some other ideas, do let us know. We would love to share that content. And yeah, that's it. So have a great day ahead, and thank you for watching this. See you next time. Bye bye.